Welcome. A semicircle inscribed inside a quarter circle. So here two important point. One is quarter circle. Which one is a quarter circle? Quarter circle is OAB, and AB is the quarter circumference of that circle, and a semicircle OA, here we can take a point, actually anything, let's say x. So OXA is a semicircle which is inscribed inside a quarter circle. What we have to calculate? We have to calculate the length of the chord of the quarter circle. So quarter circle is of course OAB, and the arc, the chord BP is what? That we have to calculate. And that chord of the quarter circle, that is also a tangent of the semicircle. So let's say here a point where the tangent of a semicircle of OXA. From the figure, semicircle of course inscribed, and here a very important point, that the semicircle diameter is 30 centimeter. This is also given. Now if we redraw this picture like this, where the center of the semicircle is S and the tangent point Q, as the OA is equals to 30, it means, and of course this point is S, so OS is 15 centimeter and AS is 15 centimeter, because S is the midpoint of OA. And here is another important point, I mean the redrawing, and here OB is 30 centimeter, because OA and OB is the radius of this quarter circle, as OA and OB is the radius of the circle, which is 30 centimeter, because OA is 30, so OB also 30 centimeter. And BQ as the tangent from B, so BQ is equals to OB, so this is also 30 centimeter. Why? Because tangent from B. Now to solve this problem, let's assume that PQ, so PQ, so this point is P, and the tangent point Q, this PQ, let's say A, as well as KP, the OA extended to K, it means PK is equals to B, PK is equals to B, as well as AK is equals to C. We assume this 3 point, and again what we have to calculate? We have to calculate the distance of BP. So we already have got the value of BQ. Now what is our target to calculate or determine? That is PQ, right? Now another important point is, now have a look on triangle BOK and triangle QSK. So this is B. Let's change a different color pen. Let's use this one. So this is actually BO. Okay, BOK, and this one. So this is BOK. This one. Now QSK. So this is QSK. Let's change the color. Okay, so this one and this two triangle are actually a similar triangle, right? So this two triangle is a similar triangle. Why? Because angle of OKB is this one, which is equals to SKQ. These two angles are equal because these two triangles are similar triangle, and of course the angle of BOK is equals to angle of SQK. Let's have a look. So BOK, so this point is B, OK, this angle, and SQK, so SQK, this is equal, and of course they are right angle triangle. So when two triangles are similar, when two angles are equal and another two angle also equal, or within a triangle, if two angles are equal, in that case we can say those two triangles are equal, right? From this phenomenon we could write down the ratio of OB over QS from this two triangle, OK over KQ, also equal to, we could write BK over K of S. Now let's plug in the value. So the value of OB is equals to 30 and QS is of course 15, is equals to OQ. So this is OQ is 30 plus C. So 30 plus C over KQ is equals to A plus B. So KQ, so K is here and Q is here. So up to this length, up to OP is B, and from Q to P is A, and this is B. So A plus B. Also we can write down 30, I mean the value of BK is equals to 30 plus A plus B over 15 plus C. Now solve this problem or the equation. Here of course 2 is equals to 30 plus C over A plus B. Here 30 plus A plus B over 15 plus C. Now we could write down 2 is equals to 30 plus A plus B over 15 plus C. So here 30 plus 2c is equals to 30 plus a plus b. So here it will be 2c is equals to, from both sides 30 cancel out, a plus b. So let's write down, this is one equation, and also we could write down 2 is equals to 30 plus c over a plus b. By solving this equation, we could write down 4c is equals to 30 plus c, or 3c is equals to 30. So from here we could write down c is equals to, so here c equals to 10. From or the figure we could write down Ka. So this is Ka times Ko. So this is K, and up to this much is Ko is equals to Kp. So up to this much is Kp, right? Better to use the yellow pen. Okay, so again Ka times Ko, and here Kp up to this much times Kb. So it will be Kp times Kb is equal. Why? Because intersecting seconds theorem actually. So this is the intersecting second theorem. Okay, now the value of Ka is actually 10, and Ko is equals to 30. Actually first 10, because Ka plus up to this point is actually 60, right? Because the quarter circle up to this much, the radius was 30, so the whole diameter is actually 60. So up to this much it will be 60 is equals to the value of Kp. Kp is b times Kb. Kb is equals to 30 plus a plus b. Right, now we have to solve the equation, and after solving the equation we straight away write that b is equals to, because b is the only variable here, so b is equals to actually 14 centimeter, right? And we know that a plus b is equals to actually 20. The star equation, right now we have solved that a plus b is equals to 20. Now it's time to plug in the value of b. Indeed, we have the value of a is equals to 6 centimeter. Now the chord PB is equals to 30 plus a, right? So the chord is 36 centimeter. So this is the final answer. So the chord PB is equals to 30 centimeter. So this was the chord from here to up to this much. So B to Q is 30, and from Q to P it was A. So 30 plus A, it means instead of A is 6, actually the value of A is 6. So the final result of BP or PB, whatever, this will be 36 centimeter.